even if you are given this angle, okay, you know this is 90, you subtract whatever angle given here from 90 to give you this. So you must use the angle between the vector and the horizontal to solve. Okay, now we are considering vertical component. Let's start with F1. F1 is on the horizontal. You can see is on the horizontal. Any vector on the horizontal is considered to be 0. The angle is considered to be 0. But if the vector is on the vertical, the angle is considered to be 90 degrees. Let's resolve. So it means that we have this one. I told you we are going to be, for vertical component, we are going to be using sine theta all through. So we have F1 sine theta. Theta 1. The theta 1 is on the horizontal, so that's why you're not seeing it on the diagram. Then the second one will be what? F2 sine theta 2. Then the third one is going to be what? F3. Let's be true with all before we put the signs. F3 sine theta 3. The next one is what? F4 sine theta 4. The next one is what? Which is the last vector, is F5 sine theta 5. Okay, now let's ascribe the signs. I told you before that the vectors that are up is going to be positive, while the vectors down will be negative. Okay, let's do this. Now F1 is neutral, it's neither up nor down, so we consider it to be neutral. We don't put any sign. Then F2 is up. I told you all vectors up is going to be positive, so we have plus here. Then F3 is also up, is going to be what? Positive. F4 is down, is going to be what? Negative. F5 is down, is going to be what? Negative. Okay, so if you are given the angle and you are given the force, you multiply with the sine theta of it, then you get your final answers. Are you following? Now the summation of all this, the total of all this, whatever you get here, whatever you get here, whatever you get here, whatever you get here, you add them, you sum them, whatever it is going to be your vertical component. Okay, so now after you're done with the vertical component, you also resolve to the horizontal component. Oh, sorry. We resolve it to what? Into horizontal components. So, resolving it to horizontal component means everything we are going to be doing here is going to be what? Cos theta. Like I said, the vectors on the right, in this case, will be considered positive, while the vectors on the left will be considered to be what? Negative. Okay, so now let's start with vector the vector 1, which is F1. So we have F1. Let's finish bringing it out like this. F1 theta 1, and we have F2 cos theta 2. Okay, F3 cos theta 3, and then we have F4 cos theta 4, and finally we have F5 cos theta 5. Now let's look at it. Now, like I said, considering it, doing the horizontal components, finding the what? Horizontal components, every vector on the right is considered to be positive. So F1 is what? On the positive side. So this is going to be what? Plus. F2, look at it. F2 is what? On the right side. So it's going to be what? F2 is on the right side. So it's going to be positive also. F3 is on the negative side. It's on the left side rather. is going to be what? Negative. F4 is on the left side. This is also going to be what? Negative. F5 is neither here nor there. It's going to be what? Neutral. I hope we are communicating. So we also do the same thing after, if you are input what you are given as F1, F2, F3, F4, you find the cos theta of the angle, you get an answer here. The summation of this is what we have as what? Our horizontal, the total horizontal component. So usually we call this vertical component is what? I mean Fy. And this one is summation EFX. Okay? So it means that the resultant, when you are looking at two or more vectors, R will now be equal to, if Fy plus EFX. This is our resultant. Okay? This is our resultant. So we have our resultant. This is our resultant. So now you want to find the direction. So when you do your summation, you get a particular value here, you get a particular value here from here. What I mean. So we have our y will now be a single magnitude. It will now be a single magnitude, and our x will also be a single magnitude. Okay? So it means we can now represent those vectors in components, y and x. So we come down to this. And then this is going to be the resultant. After you have done this, you have a particular value, which is now going to be our resultant. Okay, maybe in the next class we'll solve practical problems that will help with the understanding of this. Okay, thank you very much.